So let's talk a little bit about type conversion. Type conversions when you want to take, say, an integer and turn it into a floating point, or a floating point to an integer. We can also do stuff like a character to a integer. We could do floating to doubles. And this double arrow is just saying this right here without doing it into lines. So there's a couple types of type conversion, and the first is going to be implicit type coercion. And that's when we take a value of one data type and automatically change it to another data type. And this is seen pretty much in mixed data types in arithmetic. And this is the biggest example we've seen of this so far. And I think the only example we've seen of this so far. So let's just note back on that. That's when we take an integer and we add it to a floating point. It could be any operator there. And that integer gets turned into a floating point number and then added together with the floating point number here to equal the floating point number that we get as a result. There's also typecasting, and that's going to be also called type conversion. And that's explicit type conversion through the use of a cast operator. And this is the syntax for it, which is going to be static cast. We're going to put our data type inside of these. I'm not sure what they call those. We'll call them brackets for now. They're not brackets, but they're some sort of bracket. So we'll put our data types such as int or bool, etc. And then our expression, which it can be like, we could put like 1.0 in here, or we could put true, or we could put something like 1 plus 2.5 in there, and then put int here, and we would get an integer. We can really, as long as we're sticking to like these rules where we're only staying in, because as you notice, these are both floating points. These are all integrals. So as long as you're staying within the proper category, you can static cast them easily. So this is an example of it. If we take, even to further iterate this, if we take, say, 1.5, it will get cast down to 1 still. Anything here. If we were to put 1.572936, that would get cast down to a 1 still. Okay, now let's switch over to the computer so we can look at this a little bit further in our programs. So this is just a pretty basic C++ program that we've gone over. We'll review that in a little bit as well. And we could do simply just to display, for display purposes, we can just see out this. And so we're going to do a static cast. And let's just say to an integer for now. And let's try 1.5. So we can save that. We can grab a terminal. we're at our desktop. We can compile our program. And then we can test our program by running this a.out file that gets created. And you notice the 0.5 gets chopped off in this case. We could do something like static casting this 15 to a double, which, let's say we want to do 15 divided by 2. And let's take away the static cast for now. As you notice, we get 7. Bring back that static cast. We get 7.5. Why is that? Well, previously, we were taking 15, dividing that by 2, which gives us, those are both integers, so we get an integer result back. But when we static cast to a double this 15, we get a double, which turns this into a mixed expression. And this gets cast implicitly to a double, which gives us a double result out, 7.5. We can also further look at this by just moving this one parenthesis and recompiling our program. And you notice we get a 7. Why is that? Well, in this case, we take 15, which is an integer, divided by 2, which is an integer, and then we static cast it to a double, which is 7, because we get an integer result from here, which is 7. We can also say static cast a to an integer. Let's see what we get when we do that. We get 65. Why is that? Well, if we look over here on our ASCII table, A, the capital A, is 65, which is what we got out because characters follow the ASCII table. And note, it isn't the lowercase a, which is different at 97. If we wanted that, we would want to put in the lowercase a, save our program, compile it with G++, and then output it, which gives us 97. And similarly, we can take that 65 and cast it to a character, and we'll get the capital A as expected. And then we can also get 97, which would give us something like this. Also note, we could do something like, what's 97? So 97 minus 65 is 32. So we could do something like this. We could say 97 minus 32. And that would give us capital A. So that's pretty cool. And also, we really don't need any of this because we can just do that and it will still do the cast. So really, this kind of makes the static cast obsolete, but to each their own, and feel free to use whichever you would like.